Hi, welcome to tutorials on Vishal Financial School. Today we are going to learn how to calculate an option price using Black-Scholes model. Before we start, there are a few assumptions which Black-Scholes model uses before calculating an option price. So these you will be getting in any of the derivatives books, so I will not be focusing much on it. Let's start with a problem to understand how to calculate the same. Before I start calculating using a problem, let me just give you a focus on the formulas that we use. The formula 1 is used to calculate the call option price. The most important thing is we need to find the D1 and D2s. The formulas that we use for calculating D1 and D2 are mentioned here. In few books, the D1 formula will be also mentioned in this manner. Both the formulas will end in giving you the same result. So do not be scared saying one of the books is following one method, another is another, but both will end up the result giving you same answer. D2 is this. So let's take up a problem to understand how to solve it. So stock price I have taken it as 90. Months for expiration is around 6 months. Risk-free interest rate is 8%. And the standard deviation is around 23% that I have taken in, and the exercise price is around 80 rupees. Option that we have to calculate is call option. So let's get started. Given S is 90, K is 80, R is 8%, T is 6 months. If I convert that into time, 6 divided by 12, 6 is the number of months that we need to divide by 12. That is 1 by 12 will give me for 1 month, into 6 will give me for 6 months. 6 by 12 gives you 0.5. So T will be now used as 0.5. Standard deviation is around 23%. D1 formula is what you have seen in. So once we start calculating, we will be interpreting all these as ln log normal distribution 90 by 80 plus 0.8 into 0.5. 0.8 is nothing but 0.08 is nothing but the rate of interest. T is 0.5, right? And standard deviation is 0.23, that is 23%. So I have taken it as 0.23 root of 0.5, which is the time, plus 0.5 into 0.23 root of 0.5. So how to calculate ln from your calculator? It's nothing but you have ln here, press ln bracket 90 divided by 80, enter, you will get something, or press is equal to, you will get the ln answer, right? So that was very simple of understanding how to calculate something called as D2. D2 is also the same method. The formula that we have encountered, it's very simple. First is D1 minus standard deviation root of time. So D1 we have calculated is 1.0515 minus 0.23 root of 0.5. You get around 0.889. So you have found the value of D1 and D2. We need to calculate normal distribution of D1 and D2, which is represented in this manner. So let's get understanding. It's very simple again. So let's find for D1, which is n bracket 1 minus 1.0515, which is written in the form of n bracket first 3 letters 1.05 plus next 0.15. So 0.15 into n 1.06 minus 1.05. 1.06 nothing but one number next of the previous number and the same number. That means 1.505 value lies between 6 and 5. That is reason 0.5 into the difference will give me the 0.5's value, which is of this. So how does this gets calculated? I have shown you. You will get an log normal table which is in this form, where I need to find 1.0 value, 1.0, 1.0, right, and 0.505. So it will be around 8.0 0.8531, which is the number that I have written here. Simultaneously 1.06 log normal distribution. How do we calculate? It is the same method by which we are calculated log normal for 1.05. The same thing that we have mentioned there. When we tend to solve this, we get around 0.8547. So this was for ND1. ND2 you have got the same process that we tend to get used in. So 0.88, the next version of is 89 minus 0.88. So you get around 0.831. So now you have got ND1 value and D2 value. All you have to put it in the formula which we use for call option, and you tend to get the answer. I have taken the exponential E value as 2.7182, or in case if you are well versed with calculator, you can use it by putting e raised to the value that has been put across. So this was a method by which Black and Scholes model is being used to calculate an option price. We wish you a very best in learning. Happy learning, and we will see few more videos from us very soon. Any improvement we will definitely make and keep you posted. Thank you and happy learning.